So there are 4 homeworks due on Wednesday night. I've had a number of homework questions sent in. Thank you to those folks who sent in some questions. We can look at those in a minute. I'll just remind you that test 2 is passed back. Looks like most people have taken a look at that, which is good. But just look for that email and keep in mind that the solutions are on Blackboard. Please let me know if you have questions about that. We could talk about, homework questions during these sessions too, if that would be helpful. And I've got, the rest of the semester sort of laid out here schedule-wise. We're going to work through a few more sections. We've got homework due, this Wednesday and next Wednesday, and then we'll have our final exam 2 weeks from today. And so I posted final exam topics and practice problems on Blackboard under test topics and solutions. And so, you have 2 weeks to start getting stuff ready. It's a comprehensive exam, covers everything in the course. And I'll remind you that I think I'm going to let folks bring some material into that test to maybe reduce some of the stress related to that. Okay. So I had some homework questions. Before we look at homework, were there questions about the notes at all? Technically you should have been, if you're keeping up with the, the schedule, you should have watched the solving logarithmic equations and exponentials homework, section. And that's one of the homework sets due on Wednesday. And I had a number of questions from the homework from those sections. But is there anything in the notes first that it would be helpful to iron out before we look at the homework? Like, the progression here is hopefully you should understand the notes, and then you work on the homework, and then you crush the tests, right? And so I'd like to start with the notes if there are specific questions about that. And keep in mind, I'm happy to review a section or redo a problem or something that didn't make sense. Whatever would be helpful for you, I'd be happy to do. So if no one has a question, I'll sort of say a spiel, but I'm going to shut up for a second and see if anyone wants to say something. Okay, if there's no specific questions about the notes, let me just say a couple things, just sort of summarizing a couple general ideas. So we know, hopefully have an idea of what exponentials and logs are separately. What this page is all about is how we can take logs that are combined, like on the left, and separate them, or it's how we can take things that are separated, logs that are separated, and combine them. And there's a whole bunch of examples on this page about how to do that. That was technically what you should have watched for yesterday. Now, this becomes important in the next couple sections, because if you're trying to solve an equation that looks like one of these things on the right, like logs being added, for example, then you need to first combine them together before you solve the equation. And so keep that in mind when you're looking at solving equations. And then I had mentioned this yesterday. These were some of the notes I wrote yesterday, which is when you have an exponential equation, you use logs to solve. And when you have a log equation, you change it to an exponential to solve. And so that's where this property up at the top here, this tells you how to change between logs and exponentials, becomes pretty crucial. And so that's what a lot of the solving, sorry, my phone's ringing. A lot of the problems where you have to solve logs involve doing that. So let me first start with this homework question. If there aren't other things people want to add, I'm just going to stop one more time. No one wants to add something real quick. Okay, so this is a pretty common question. I definitely put questions like these on tests, where you have 3 separate logs. All 3 of them are log base 2, and you want to combine it into a single log base 2. And then you just enter whatever's inside there in the answer here. And so this is a combination of both those properties that I just put up there a second ago, because we have things being added, we have things being subtracted, and we've got these constants out in front that we need to deal with. And so if you remember from the notes, if you want to combine something with a number out in front of it, like this one I'm pointing to right here, the first thing you need to do is bring the 1/2 into the exponent, right? So you need to use this property to get rid of the thing in front of the log. And so the first step on this problem is to take the 5 and bring it inside, and take the 3 and bring it inside using property number 3. So I'll just make the note, this uses properties on page 85. And first we're going to bring the 5 and the 3 inside the logs like this. It goes into the exponent there, and the other one goes into the exponent here. And the reason you need to do that is because all these properties that we want to use on the top here, like in a second, we will have things being added that we'll want to combine, and we have things being subtracted that we want to combine. But if you look at the properties on the right, there's a 1 in front of all these logs that I'm pointing at, right? There's not a number in front of them. There's a 1, technically. And so if you have a number, you need to first move it inside using property 3, and then that opens up property 1 and 2, right? And so now we're in a situation that looks like property 1 and 2. This one we'd use property 1. And then the second 2, we have subtraction, we'll use property number 2. It doesn't really matter which one you choose, which one you do first, as long as you're just careful and you do it correctly. Right, so property 1 says when you have 2 logs being added, you can combine and multiply. And so I'll do that one first. And so this becomes log base 2 of x times y to the 5th. Right, so I just combined those 2 separate things and multiplied them. And then the last property says if we have them being subtracted, we can combine them by dividing. And so we can combine those together by dividing. So log base 2 of x y to the 5th over x squared. And so that's it being combined into 1. And that's pretty much the bulk of the problem. You can simplify it a little bit more because you've got an x on the top and the bottom here, right? And so you could technically combine those exponents, right? You could subtract, this is an x to the 1. You could subtract 1 minus 2 to get this simplified version. I'm not super picky about that on a test. Like if this is a test, I would probably be fine with both of those. What's important to me is you know the properties, not so much the exponent thing there. WebWork a lot of the time wants things simplified. And so if this is me, I would probably enter this into WebWork, right? And so the way WebWork wants this entered, it just wants you to enter what's inside the log. And so this is what you would actually enter into the problem. You enter y to the 5th over x. Thoughts about that one?
What's the name of the web work that this problem's on?
It's logarithmic properties number 4. Can you not see that heading? It's visible on my screen. I'm just curious if you can't see that.
I can see it now since you moved it.
Other questions about this one? Or other ones from this section? Right, this section is all about combining logs, which, as I mentioned a second ago, is important, especially when you're going to solve equations. And so, you know, most of this section is mostly just practicing so that when you come to solve equations, you know how to do that. Hey, folks, just give me 1 second. Sorry about that. Okay, no other questions about this one? Go on to the next question I had. So the next couple questions I had were all about solving equations. So when we're solving equations, we need to keep the following in mind. So if you're solving an exponential equation, which is the first thing we're going to talk about, so a to the x equals y. If you want to solve for x, right, if you want to get x by itself, what you do is you use log base a on both sides, because when you have log base a and exponential a, they cancel. And then the x just comes right down. And so this would be the answer for this particular one. And I know they look weird, but log base a of y, it would be some number. And so you can just leave it right like that. Now, the other thing we talk about in the videos is you can really technically use any log to do it. So you could just use natural log, for example, which is what you have to do in the homework, because the homework doesn't know anything else other than natural log. But since these have different bases, right? So ln is log base e. We talked about that yesterday, right? And so these are now different bases potentially. And so they don't cancel anymore. But you can use the property we were just using a second ago to bring this exponent outside. So it becomes this. Oops. All right. And these two things are just numbers. And if you want to get x by itself, you would just divide these things to the other side, and you'd get this as an answer. And so these are equivalent answers for the same problem. And I know they look different, but if you plug them into calculators, they would be the same. And so you have options about which one to do. I would suggest on tests and things like that, this method's easier, right? So I would use this on tests or the final, for example. But web work, you don't have a way to enter log base anything other than e in web work. Web work only knows natural log or log base 10. And so if you're doing web work, you would have to do it this way. So just keep that in mind when you're working through those things. I do apologize for that, but having said that, it doesn't really matter. It just sort of forces your choice of what to do. Can I answer a question about that before we look at a couple homework problems? I've got some questions that someone asked right here, and so I will put those up. So on this first one, I know it's hard to read. I will rewrite it. This one says, this is the first question in exponential equations. And the first thing you need to do is you need to isolate the 2 to the t over 14. You got to get the exponential by itself. In other words, divide by 48 to get the 48 out of there. Because we want to do what we just did a second ago and take log base 2 of both sides to get this by itself. Except since this is web work, we'll just use ln. So what I'll do is, you're trying to get t by itself, right? So you're going to ln both sides, natural log, and then you bring the t over 14 down in front. I'm just going to leave this as 340 over 48. Now, ln2 is some number, and 14 is some number, right? And so we want to get rid of those two things to get t by itself. And so we can start by dividing by ln2. I'll just kind of do it in 2 steps, right? And then you can multiply by 14 to bring it over to the other side, and then t would be by itself. And so I know this looks ugly and it looks like some big, huge thing, but I would just try to enter it like this. Don't try to put it into a calculator and get a bunch of decimals, because one of the problems with getting decimals is that web work oftentimes requires different numbers of decimals for each problem. And I have no idea how to change that. I've tried, I really have. And so to avoid entering decimals into web work, just enter this. You can enter that and it will accept that. And yes, it's ugly, but it is some number. So that's the general idea behind those, right? You isolate the exponential, you bring down the power using natural log, and then you get the variable by itself. That's the general approach to all these. Sorry, go ahead.
You get 4n on a second step. Or is it ln, or is that folks like 4n?
I'm taking the natural log of both sides. It's ln.
Oh, okay. Gotcha.
All right, so you have a to the y equals x. I'm doing ln of both sides like that. No, that doesn't look much better, but that's what I'm doing there. That's what lets me bring down the power, right? So we know that when you have a power inside a log, you can bring it down in front. And so we're trying to sort of create that situation so that we can bring the t over 14 down in front.
Hey, Dr. Levy,
Hey.
would it still accept the answer if the 340 over 48 was simplified?
Yeah, sure. Yep.
Okay.
Absolutely. I would just try to avoid plugging decimals in there again, because like if you, I don't know what that equals, but if you don't plug in the right number of decimals, it might not give you a close enough answer that WebWork is looking for or whatever. So keeping it as some fraction would be preferable. Other thoughts about that one? Got another one here. So this other one is more of the harder variety. These are kind of the harder kind of questions. Let me rewrite it again because it's hard to read. And so since this is, again, WebWork, we're going to want to use natural log. And so I want to get the x out of the exponent. And so I'm going to take the natural log of both sides, because, again, that's going to let me bring this whole thing down in front. So you do the natural log so you're able to take out the exponent. Again, right? Because we want to get x by itself, and so we got to get it out of the exponent first. And notice how when I'm rewriting this, I'm writing everything in parentheses. That's important because the natural logs distribute through here, right? This is some number times a quantity, and so it distributes. That's where people often mess these up. They don't put it in parentheses, and then they think, oh, this is just 7 times natural log. But they forget that it actually distributes. And so after it distributes, yes, it becomes kind of large. But most of the things in here are numbers, right? We want to get the x by itself. And so we want to, this is very similar to when we were solving fraction equations. Remember that and this, maybe that's a good review for the final. You group the x's on the same side and then factor it out. In other words, right now, there's an x on the left and there's an x on the right. And so I'm going to move things around so all the x's are on one side and everything that's not an x is on the other side. Right? So I'm going to move the 2 things that are underlined in red over to one side, and these 2 things underlined in green are going to go over to the other side. So I'm just going to do that in one step. Hopefully this makes sense. I'm going to move the x's to the left. So that would be this. And I will add that one to the right. And the whole point of doing that is because now both these terms have an x. So you can factor out the x, and then it's almost by itself. We're like right at the end here, right? Factor out the x, and now everything inside here is a number. Is it ugly? Oh yeah, it's gross. But everything is a number, right? All these ln's are numbers. The 5 and the 8 are obviously numbers. And so now you can just divide by this ugly looking number and get the x by itself. And again, I would just enter it right like this into WebWork. Don't waste your time plugging things into calculators and all that stuff. Just enter it right like that. And because it just takes all the decimals, right? You don't have to worry about decimals. This has all the decimals along with it. That's about as hard as a problem gets, too, by the way. Right? This is a hard problem because it's 2 separate exponentials. They're both raised to powers with x's. And both the powers are polynomials, right? They're like 3x minus 5. It's not even just like one thing, it's 2 terms. So if I do occasionally put ones that kind of look like this, but there would never ever be something more challenging like this on the test for sure. This is the hardest problem that one might see. And so maybe one way to think about that is if this one makes sense, you're in pretty good shape, I'd say. If not, you want to like work towards understanding this one with some of the earlier, more simple problems, probably. Questions about that one?
The previous one we just said, what was the final answer?
I'm sorry, did someone just say something?
Previous problem we just did, what was the final answer? The web work one.
The thing that I boxed in. Right, and I know that maybe you're not used to seeing, like, maybe people are used to just having like some number, some fraction or something at worst. I know this is bad, but everything's a number. And yes, you could plug this into a calculator and get some decimal. I'm just suggesting avoiding doing that because WebWork often wants like 4 decimals or 5 decimals or 3, and you never really know which one. And so it's just safer just to enter the exact value. Other thoughts about this one? The other question I had was from the next section, the logarithmics equation. And so I'm happy to look at that one, but if there's another question from this section, we should look at that first. Okay, I'm going to throw up the last question I had. Again, you're welcome to ask others. This is from logarithmic equations number 4. I will rewrite it again so it's bigger. This one's a little strange because it's a natural log inside a natural log. But anytime you have a logarithmic equation, what you do is you first combine logs using the logarithmic properties. Then you change it to an exponential. And then that'll allow you to solve. And so the way you change it to an exponential is using this idea. It's the property I wrote a minute ago. I will rewrite it right here. Right, this is how you transform between logs and exponentials. And so ln is log base e, right? So let me rewrite this one as log base e of log base e of x equals 3. Because now we can use this property. And we have to do it twice because we have 2 of them. But the first time we do log base e raised to this power, so e to the 3 equals what's inside here. And then e cubed is a number, right? It's like 2.72 cubed. So that's a number. And so then we have the same setup as we just did a second ago. And so we just use this property a second time. And so we do e raised to this power. And so it's going to be e to the cubed. It's kind of weird, but that's how it would work. And it equals what's inside there, which is x. And so that would be the final answer. The way you would enter that would be e caret parenthesis e caret 3. Because you want the entire e cubed up in the exponent. So that one was kind of funky because I had 2 of them, but you do just apply basically the same property twice. Questions about that one? Other general questions? Anyone want to chime in at all before we sign off about anything?
Question.
Yep.
So Levi, so when you plug it into the WebWork, it will be en3.
This is the caret sign. It's like it's how you write exponents, right?
Yeah.
Control 6.
Oh, so it would be okay, makes sense. You just want
Or shift, is it shift 6? I can't remember how you do that now. Shift. Other questions? What else can I do for you guys this morning? I appreciate those ones. This is sort of the most diverse group of questions I've had in terms of people asking that. I appreciate those questions. If you're sort of waiting for the night of the homework to do the homework tomorrow night, keep in mind I'm around during the day. I mean, the tutors are also available at night, of course, but I'm around during the day if you guys need anything. So if there aren't other questions, I'm going to sign off. I'm going to shut my mouth one more time and see if there are. So Courtney is wondering, yeah, so in WebWork only knows ln, right? If you do ln, it knows that's log base e. And if you just type in log, it knows log base 10. And so you're welcome to use log base 10. Yeah, there's no problem with doing that. Most people, when they solve equations just in general, I think use natural log because, I don't know, because maybe it's less writing. Honestly, maybe that's why I do it, because it's just late. But yeah, you could also use log instead of ln, and WebWork would recognize that, and that would be perfectly fine. Come on, it means one less letter. That's a lot of letters when you write it a bunch of times. Other thoughts, questions?